So top of page 3, we have a formula that I'm guessing everybody's pretty familiar with from their high school days, right, called the quadratic formula. And the quadratic formula is actually the solution to the quadratic equation in one variable, ax squared plus bx plus c equals 0. Right? A, b, and c are coefficients, real numbers. And you can actually derive that formula from this equation by completing the square on the variable x on the left-hand side. We're not going to do that in here, but if you'd like to see it done, right, come to my office and we'll do it together. Okay? But you can derive that formula by completing the square on the left-hand side. And so, formula x equals negative b plus or minus the square root of b squared minus 4ac over 2a. What's under the square root? B squared minus 4ac. Usually what we call what's under the square root the radicand. But in this case, the quadratic formula, it gets the fancy name called the discriminant. And based upon the numerical value of b squared minus 4 times a times c, you can determine how many solutions there are to this quadratic equation, right? How many real solutions, right? Real values of x. Okay. Now later on semester, we're going to be working with cases where the values of x can be complex numbers. But right now, we're only interested in values of x that are real numbers. Okay. And so, if the numerical value of the discriminant, b squared minus 4 times a times c, is positive, right, greater than 0, then there are two distinct real solutions to this quadratic equation right here. Okay. And what that means is, if there's two real solutions, in the graph of the parabola, right, that opens up, it crosses the x-axis in two locations, and if it opens down, it crosses the x-axis in two locations. Okay. That's what we mean by two distinct real solutions. Okay, the graph of the parabola crosses the x-axis in two distinct locations. Okay. If the value of the discriminant under the square root is exactly equal to 0, there's only one solution. And that means there's only one x-intercept, which means the vertex of the parabola is on the x-axis. So there's only one x-intercept. Okay. And similarly, if it opens downward, right, the vertex is on the x-axis. Okay. So there's only one solution. Okay. If the discriminant is negative, less than 0, then there are no real solutions, and there are no x-intercepts in the graph of the parabola. The graph of the parabola is either entirely above the x-axis or it's entirely below the x-axis. It never touches it, never crosses it. Okay. All right. So in example 4, you're given a couple of quadratic equations in single variable x, and you got to solve those quadratic equations using the quadratic formula. So let's take a look at those two examples. So we have an a, x squared minus 8x plus 13 is equal to 0. So you can see that a is equal to 1, B is equal to -8, C is equal to 13 in this problem. And so to find the two solutions, well, 0, 1 are two solutions, okay, of this quadratic equation, okay, the variable x, we just substitute into the quadratic formula, right? Substitute A, B, and C into the quadratic formula, and then simplify. So we have the negative of -b. Since we have negative b, we write out the formula over here. So x is equal to -b plus or minus the square root b squared minus 4 times a times c over 2a. Right? So we have -b in the numerator, which is the negative of -8, and then plus or minus the square root of b squared. Well, b squared is -8 squared, and minus 4 times a, which is 1, times c, which is 13, over 2 times a, which is 2 times 1. Once you do all the substitution, it's arithmetic, right? PEMDAS. So you got to follow order of operations under the radical, right? And then follow order of operations of simplifying the numerator, and then simplify the quotient, the fraction. Okay. So negative of -8 is +8. Minus, under the radical, you got to do exponentiation first. -8 squared is 64. And then you got to multiply. 4 times 1 times 13 is 52. So we have 64 minus 52 under the radical. 2 times 1 in the denominator is 2. Under the radical, 64 minus 52 is 12. Now, riddle me this, ladies and gentlemen. Remember, fraction bars are like division symbols. Does division undo addition and subtraction? No. So each of these terms in the numerator have to be divided by 2, not just the 8. So we have 8 divided by 2, plus or minus the square root of 12 divided by 2. The square root of 12 reduce? What does it reduce to? 2 root 3, right? Square root of 12. 12 is equal to 4 times 3. And by the rules of radicals, this is equal to square root of 4 times the square root of 3. Square root of 4 is 2. So square root of 12 is equal to 2 root 3. Well, 8 divided by 2 is 4. And 2's cancel, right? The common factor in the numerator and denominator of that fraction. And we're left with root 3. So there are two solutions. Okay? X equals 4 plus or minus the square root of 3. So in writing out the two solutions, right, on an exam or whatever, you can leave them like that. Okay? And in my math, or not my WebAssign, I don't know if you have, no, I can't remember. You may have to break them up, write them both out. Okay? Because I don't think there's a plus and minus symbol in WebAssign, but there might be. I keep forgetting. But the two solutions, you use like the plus sign first, So the first solution is 4 plus the square root of 3. And then you use the minus sign. And the second solution is 4 minus the square root of 3. So when you have 4 plus or minus root 3, right, it's understood you use the plus sign to get one solution and then the minus sign to get the other. Any questions on that? On the next one, we have 3x squared minus 7x plus 1 is equal to 0. A is equal to 3 in this case. B is equal to minus 7. C is equal to 1. So plugging into the quadratic formula, x is equal to negative b, which is the negative of negative 7, plus or minus the square root of b squared, which is minus 7 squared, minus 4, times a, which is 3, times c, which is 1. All divided by 2 times a, which is 2 times 3. Negative negative 7 is plus 7. Under the radical, minus 7 squared is 49. And then you do the multiplication, 4 times 3 times 1 is 12. So we have 49 minus 12. The denominator, 2 times 3 is 6. Well, 49 minus 12 is 37. The square root of 37 reduce. Nada. So, and 7 is not divisible by 6, and this doesn't reduce, so you can probably stop right here. Okay? But if you need to write out both solutions, use the plus sign, and then use the minus sign. All right, any questions on that? All right, in example 5, determine the equation of a quadratic function whose graph is given. Find the x-intercepts. Okay. So, see, we have the graph of a parabola. Opens up. And you can see it crosses the x-axis here and x-axis here, but it's not obvious what those numbers are, is it? Okay. We have to figure that out. So we've come up with an equation for that parabola. And we'll be able to figure out what the x-intercepts are. Well, let's make a couple observations. Okay. Collect some information. Here's the vertex, right? Lowest point on the graph. At what point in the coordinate plane is the vertex located at? What's the x coordinate? What's the y coordinate? Negative 3, right? So the vertex is at the point 1 minus 3, right? And if we write this equation in standard form, which I intend to do, right? H is equal to 1 and K is equal to negative 3, right? Because in standard, when you write the equation of when you write the quadratic equation in standard form, right? H is x coordinate for the vertex and k is the y coordinate for the vertex. Okay. All right. The graph crosses the y-axis right here at this point. Okay. So this is the y-intercept. What is the y-intercept? -1. What's the ordered pair for the y-intercept? 0, -1, right? So the point 0, -1 is the y-intercept. So now we have all the information we need to write the equation for that quadratic function in standard form. So the equation in standard form is y equals a times x minus h squared plus k, right? Standard form. And so we now know h and k, right, from the location of the vertex. Y is equal to a times x minus 1 squared plus k, which is minus 3 in this case. Okay. So we put the vertex into the equation, the quadratic equation in standard form. Okay. Now we got to figure out what a is. Okay. So to figure out what a is, we're going to use the y-intercept. 0 is the x coordinate, minus 1 is the y coordinate. So we put minus 1 in for y, 0 in for x, solve for a. Then we'll know what a is. Then we'll know what the equation of the quadratic equation is in standard form. So we have minus 1 is equal to a times 0 minus 1 squared minus 3. Now you guys solve for a. So on the right-hand side, parentheses 0 minus 1 is -1, and -1 squared is plus 1. So we have a times 1, and then minus 3. Add 3 to both sides. Get minus 1 plus 3 is equal to a times 1, which is just a. So we have minus 1 plus 3 is 2, so a is equal to 2. So we put 2 in for a here, and now we have the equation of the quadratic function in standard form. Y is equal to 2 times x minus 1 squared minus 3. That's the equation of the quadratic function in standard form. Okay. Now we got to find the x-intercepts. How do we find the x-intercepts? Set y equal to 0 and solve for x, right? So to find the x-intercepts, set y equal to 0 and solve for x. So we have 0 is equal to 2 times x minus 1 squared minus 3. Now, ladies and gentlemen, we could FOIL this, simplify the right-hand side, right, and then use the quadratic formula, right, or factor, if that works. But this is already set up. This is x minus 1 squared. We can just use the square root method, right? We don't have to do the FOILing and all that. We can just use the square root method. So, gonna add 3 to both sides. Get 3 is equal to 2 times x minus 1 squared. You gotta isolate the x minus 1 squared on one side so I can do the square root method. And now divide both sides by 2. We have 3 halves is equal to x minus 1 squared. And now I'm going to switch the 2 sides. So x minus 1 squared is equal to 3 halves. And now I can take the square root of both sides. And I have the square root of x minus 1 squared is equal to the square root of 3 halves. What am I missing on the right-hand side? Plus or minus, right? When you use the square root method, there are 2 solutions, right? We use the square root method. So we're left with x minus 1 on the left is equal to plus or minus the square root of 3 halves. And I don't think it really pays to do anything with this radical because you can't reduce square root of 3 and you can't reduce square root of 2. Okay? And so now we add 1 to both sides, and I've said this in the past, right? When you add or subtract a number from both sides, you get plus or minus on the right-hand side. Put whatever you're adding or subtracting in front of the plus or minus to avoid confusion. That's what I do. And so we have x is equal to 1 plus or minus the square root of 3 halves. So those are the 2 x-intercepts, not written as an ordered pair. Okay? And so you have to write out each one. You use the plus sign, and then you use the minus sign. Okay. So those are the location of the 2 x-intercepts, right? That's where the parabola crosses the x-axis here and here. Okay. All right. Any questions on that? Okay. So you flip over to page 4. Take a look at example 6. Graph the quadratic function f of x equals minus x squared plus 3x plus 4. Determine the domain and range, the vertex, the axis of symmetry, x and y intercepts. Determine where the function is increasing and where it is decreasing. So we have f of x is equal to minus x squared plus 3x plus 4. So a in this case is equal to -1. B is equal to 3. C is equal to 4. Does the parabola for this quadratic function open up or open down? It opens down, right? Because a is negative. The parabola is going to open down. Okay. All right. So to find the x coordinate for for the vertex, location of vertex, x is equal to what? What's the formula? You remember? It's negative b over 2a gives you the x coordinate for the vertex, right? That is from page, is that on page 1? That is on page 1. Okay. So negative b in this case is negative 3, and 2 times a is 2 times negative 1, so that's equal to 3 halves. Okay. So 3 halves is the location, is the x coordinate for the location of the vertex. The location, the y coordinate, okay, for the location of the vertex is f of minus b over 2a, which is f of 3 halves in this case. Okay. So now you got to evaluate the function up here at x equals 3 halves, right? So you have the negative of 3 halves squared plus 3 times 3 halves plus 4. So you get to work with fractions. Okay. Well, 3 halves squared, right? You square the numerator, square the denominator, right? 3 squared is 9, 2 squared is 4. So this is equal to minus 9/4. And then 3 times 3 halves, 3 is like 3 over 1, right? So 3 times 3 halves is 3 over 1 times 3 halves. And when you multiply two fractions, you multiply straight across. So 3 times 3 halves is 9 halves. And then plus 4. So to add those 3 numbers, no mixed numbers at college level. Some of you guys are still working with mixed numbers from high school. I worked with mixed numbers in high school, but we worked with improper fractions, okay, in college. The exception is like when we're doing word problems, like we did yesterday. Sometimes a decimal makes more sense than an improper fraction. So what's the common denominator for those 3 numbers? 4, right? So this is equal to minus 9/4. 9 halves, you're going to multiply top and bottom by 2. And you get 18/4. And 4 is equal to 4 over 1. You're going to multiply it top and bottom by 4. And you get 16/4, right? 16 divided by 4 is 4. So now we got 3 fractions with the same denominator. We combine the numerators and we get 25/4. Y, the y coordinate is 25/4. So for this problem, the vertex is located at the point 3 halves, right? 3 halves is the x coordinate, 25/4 is the y coordinate. Okay? What's the axis of symmetry? Yeah, remember, axis of symmetry is the equation of a vertical line, right? And so the vertical line is x equals 3 halves. Okay. So x equals 3 halves is the axis of symmetry. right? So the axis symmetry goes right through the vertex, okay? And the right half of the parabola is a mirror image of the left half of the parabola. Okay? That's what the axis of symmetry does. Okay? X and Y intercepts. Okay? So to find the X and Y intercepts, I'm going to go back to our original equation. Remember, function values and Y values are interchangeable. So we have Y is equal to minus X squared plus 3X plus 4. So to find the Y-intercept, we set X equal to 0. Well, when we put 0 in for X on the right-hand side, what does the right-hand side equal? 4, right? You put a 0 in for X, you get minus 0 squared plus 3 times 0. So the Y-intercept just ends up being equal to the constant term. Okay. So the Y-intercept is Y equals 4. Okay. Actually, in my notes, I put 0 for X. So let's do that. Y is equal to minus 0 squared plus 3 times 0 plus 4. So we end up with Y is equal to 4 or to the point 0, 4. For the x-intercepts, right, you set Y equal to 0, solve for X. And it's usually not as much fun, right, finding the x-intercepts. So, put 0 in for Y, and we have, and I'm going to switch the two sides of the equation at the same time. Put 0 in for Y, switch the two sides of the equation. And I commented yesterday, all right, now we can try to factor the left-hand side. The left-hand side does factor with integers. The difficult, and I said yesterday, I have a hard time factoring when the number in front of the x squared is negative. Now, some of you guys can do it, right? I'm happy for you. But I'm just not wired that way. My brain's not wired that way. So I'm going to divide both sides of this equation by -1 to create an equivalent equation. And you know, when I divide the left-hand side by -1, each of these, the sign of each of these coefficients change. So minus x squared becomes plus x squared, plus 3x becomes minus 3x, plus 4 becomes minus 4, and 0 divided by -1 is still 0. Okay. And now this I can factor. Okay. This factors into x minus 4 times x plus 1. So we have a product of two factors is equal to 0. So either the first factor is equal to 0, or the second factor is equal to 0. When I solve for x, I get the two x-intercepts. X equals 4 is the first one. X equals -1 is the second one. Now I notice that in WebAssign, they often want you to enter the x-intercepts smallest to largest. So you got to be careful about that, right? If that's the way we want them entered, you put 4 in first and -1, and it'll tell you you're wrong. Because -1 is smaller than 4. Okay. And then as an ordered pair, we have this x-intercept's at 4, 0, and this one's at -1, 0. All right, so now we have location of the x-intercept. What's the domain of our quadratic function? Yeah, all root numbers, right? Every quadratic function, right? And quadratic functions are actually a type of polynomial, degree 2. Okay? And all polynomials, the domain of all polynomials is all real numbers. So the domain for all quadratic functions is all real numbers. And remember, the domain applies to the variable x. Okay? So any interval notation, inequality notation. Okay? Now, the range may not be so obvious. Okay? So let's see if we can come up with a crude graph of our parabola over here. We know where the x-intercepts are, right? They're at -1 and 4. The y-intercept is at +4. Right? So it crosses the y-axis here, crosses the x-axis here, and here. And the vertex is at 3/2, 25/4. So 3/2 is the same as 1 1/2, right? It's halfway between 1 and 2. And 25/4 is the same as 6 1/4. So I may not have done this high enough. So here's like where 25/4 would be, right? That's equal to 6 1/4. Yeah, put that in the wrong spot. 1 1/2 is like right there. So this is the vertex at 3/2, 25/4, and then so the graph goes down like that, down like that. That's a poorly drawn parabola. Not much of an artiste, but you get the idea, right? So the range are the y coordinates, right? Is there a maximum y coordinate in this graph? What's the maximum y coordinate?
25/4.
Yeah, 25/4, right? It's at the vertex. 3/2, 25/4, right? That's the maximum y coordinate. Is there a minimum y coordinate? No. So the y coordinates go from -infinity up to 25/4. That's the range. Okay. Do we include 25/4? Yeah. So this is y less than or equal to 25/4. Okay, that's the range. Okay. Now we haven't really talked about increasing and decreasing, but in math, right, we read a graph from left to right, and I like to view graphs of functions and equations as profiles of hills and valleys. So if I'm down here and I start walking from left to right, I'm going to walk uphill until I get to the vertex, and then I'm going to walk downhill after I reach the vertex, right? This is the top of the hill. So the function is increasing where I'm walking uphill. From here on the left up to here. Okay? And we write the interval where it's increasing in terms of the variable x. So there's no minimum value of x. Right? So we start at -infinity, And then up to x equals 3/2, I'm walking uphill, and the function, we say the function is increasing. So it's increasing on the interval from minus infinity to 3/2. For x less than 3/2, I am walking uphill. And I get to the top of the hill, and I walk downhill forever after that. And where I'm walking downhill, I start at x equals 3/2, and it never ends. So it's from x greater than 3/2, I'm walking downhill. And how do we write x greater than 3/2? Three halves, comma infinity. That's how we write x greater than 3/2. So for x less than 3/2, I'm walking uphill. For x greater than 3/2, I'm walking downhill. So where I'm walking uphill, the function is increasing. Where I'm walking downhill, the function is decreasing. Okay. I think we've answered everything on this one. Have we not? Okay. All right. Free falling objects. So in example 7, from the top of the building, 160 feet high, a ball was thrown upward with an initial velocity of 64 feet per second. And so the height of the ball is given by this quadratic equation. Okay? S is equal to minus 16t squared plus 64t plus 160. When did it reach its maximum height? Okay. So let's draw a picture of this problem. So let's use the first quadrant. The coordinate plane. Here's the origin. Okay. And instead of the x-axis, we have the t-axis, right? T is for time. And instead of the y-axis, we have the s-axis, right? The s is the height of the ball as a function of time. Now we're told that the ball is thrown from the top of a building 60 feet high, or excuse me, 160 feet high. So here's the building, and on the vertical axis, right, the top of the building is at y equals 160, right, on the vertical axis. Now the ball is thrown upward, and then due to gravity, right, the ball stops going upward, and then it falls back down to the earth, down here. Okay, this is the surface of the earth, and this is the top of the building. Okay. So the height of the ball as a function of time is equal to S of t equals minus 16t squared plus 64t plus 160. Okay. And you can see at t equals 0, this on, right, at t equals 0, put in 0 for t on the right hand side. The right hand side equals 160, which is the top of the building, right? So at t equals 0, right, the ball is at the top of the building. Okay. Are you with me so far? Okay. So A, when did it reach maximum height? Well, the maximum height, right? We don't have a complete parabola drawn here, right? If we extended the parabola over here, right, it would come all the way down here. the height of the ball, the maximum height of the ball, is at the vertex of the parabola. Okay. And we know how to find the x coordinate, or the t coordinate in this case, for the vertex, and then the y coordinate. And the y coordinate is the maximum height of the ball. Okay. So when did it reach maximum height? That's the first coordinate of the vertex. The value of the first coordinate of the vertex. Well, here's our quadratic function, right? A is equal to negative 16. B is equal to 64. And C is equal to 160. Right? Those are the coefficients of our quadratic function. So the first coordinate of the vertex, t, is equal to negative b divided by 2a. Right? Same formula from all the other quadratics, okay, where we're finding the vertex. Well, negative b in this case is negative 64, and 2 times a is 2 times minus 16, and so we have minus 64 over minus 32, which is equal to 2. So t equals 2 seconds. Two seconds after the ball is thrown up into the air, it reaches its maximum height. And we got that by calculating the first coordinate of the vertex. And always know what the units are, okay? Because units are important. What was its maximum height? Well, its maximum height is given by the value of the function at t equals 2, right? Which is the y coordinate of the vertex. So s of 2, in this case, is equal to minus 16 times 2 squared plus 64 times 2 plus 160. And when you do the arithmetic on the right-hand side, you get 224 feet. When will the ball reach the ground? How high above the ground is the ball when it hits the ground? If that makes any sense, what I just said. 0, right? The ball's 0 feet above the ground when it hits the ground, right? So we set S of t equal to 0, put 0 for S of t, and then solve for t, right? Quadratic equation, solving for t. So S of t is equal to 0 when the ball hits the ground. Okay? So we put 0 in for S of t over here, and I'm going to switch both sides of the equation. Minus 16t squared plus 64t plus 160 is equal to 0. Now, I gotta clean this up. Now you could use the quadratic formula at this stage, but you're gonna be working with some mighty big numbers. Okay. Now on the exam, you'll get numbers that you can work with, right? Because there are no calculators. So I wouldn't never give you something like this. Okay. So each of these numbers, coefficients, is divisible by 16 or minus 16. So we can factor out a minus 16. And what we're left with is t squared minus 4t minus 10 in parentheses. Okay. Minus 16 times t squared is minus 16t squared. Minus 16 times minus 4t is 64t. Minus 16 times minus 10 is plus 160. And now if you divide both sides by minus 16, the minus 16s go away on the left, and 0 divided by 16 on the right is still 0, and so we have t squared minus 4t minus 10 is equal to 0. With a equal to 1, b equal to minus 4, c equal to minus 10. That does not factor with integers. You got to use the quadratic formula. And so we have t is equal to negative b, which is negative negative 4, plus or minus the square root of b squared, which is minus 4 squared, minus 4 times a times c. All divided by 2 times a, which is 2 times 1. Now I'm going to cut to the chase. You can verify this. But I ended up with t is equal to 2 plus or minus the square root of 14. Now you'll get better numbers than these on the exam, so don't freak out. Okay. And so there are two values of t. T equals 2 plus the square root of 14, and t equals 2 minus the square root of 14. One of these numbers is positive and one is negative. The one that's negative doesn't work. So the one that's positive works. Which one is that? You're raising your hand. So
2 plus square root of 14.
Yeah, 2 plus square root of 14 is positive, right? Positive plus positive. Square root of 14 is actually greater than 2, so this is a negative number. 2 minus the square root of 14. It doesn't work. And now you need a calculator, which you don't get on the exam. So it turns out to be about 5.74 seconds. Alrighty? And now you can do the WebAssign homework. Okay? So let's take our quiz.